We're going to take a look at particle goals now, and this is a new feature for 4.0. So the first thing we're going to do is create a simple cube. We'll set that to a length of 3, and we're going to end up using this as our goal object. So there's a few ways to create goals. We can go through the Modify menu, Modify Particle, Add Goal. Also with the P-type, we can go into the actual P-type PPG. There's a Goals tab where we can specify a new goal. So if I select New Goal, that initiates a picking session where I can select my goal objects, right-click to end the picking session. The goal item gets added to the P-type, and we can actually just look at the goal PPG by right-clicking, going Inspect Item. And now that we have a goal created, you can actually get to that PPG by going Inspect Goals. All the goals get listed here. And that property actually sits under the object you selected as a goal, much like obstacles do. So if you look under the cube, you'll see you have a cube goal property. That's what we're looking at right now. So let's just go over a few of the different behaviors for goals. If we start from the beginning here, we've got chase. And chase is fairly simple. What it does, it basically mimics the behavior as the goal acting like a magnet for the particles. So you can see the particles basically head towards the goal object, and given enough time, they'll actually reach it eventually. If we increase the timeline here to 100, you'll see the particles come down and actually end up reaching the cube. If we go over to flee, this is kind of the opposite of chase. So the particles are actually repulsed away from the goal object. So as we move this around, we can kind of push the particles away in different directions. If we look at arrive, this is quite similar to chase, except the particles sort of arrive more gradually at the actual goal object. So here we can actually modulate the distance that we arrive in Softimage units from the object, as well as the deceleration. So in this way, we can sort of slowly reach it, and we can control the actual acceleration. So what we can do is actually set the landing distance quite a bit more ahead, and then increase the deceleration so they come to a virtual stop before they reach the object, or they drift upward. If we use a negative deceleration, we're basically accelerating the particles, so they travel faster and overshoot the object. Hooke's law. Basically, Hooke's law, what it does is it states a system of springs and dampers that connect the goal object to the actual particles. So let's just set the viscosity to something like 1 and translate this around. So we've got a couple of variables to play with here. The first one is the spring constant. So I've got it set quite high right now. And what the spring constant does, basically, as we increase it, it becomes more attracted to the goal object. And we also introduce a sort of elastic quality into the springs. As you can see here, the particles are traveling very quickly towards the goal object. And once they reach it, they sort of overshoot it and swing back around. And that's because we have the spring constant set quite high. If we bring this down, you can see there's less of an overshoot, and it travels a lot slower. So we can actually go in the negative direction. So this is almost like a repelling force. But again, because we have an extreme value there, there's a certain elastic quality that have been inherited by the particles. So you get a sort of a springy behavior. So what we can do is actually the viscosity is basically used to simulate resistance for the particles. So mimicking the behavior as if it's traveling through a fluid. So as we increase that, you can see we're slowing down the particles considerably as they're having a harder time traveling, and they'll reach the object rather than overshoot it because of the resistance. And then with negative viscosity, we're basically removing any resistance for the particles, so they're free to travel very quickly, and you can see them definitely quickly overshooting the object, and they continue traveling because there's so little resistance. So if we have it at You can see eventually it'll come around. So there's a lot of neat stuff to play with here to actually create some special effects. The next thing we want to look at is actually how the target stuff works. So let's move that over here. So currently what we're doing is we're targeting the surface of the object. So let's increase the resistance a little bit and just have it aim at the actual cube. Something like that. So it's targeting the surface of the goal object. So you can see the actual particles are landing around the face of the cube. We can go to something like points. So in this case, what's going to happen is the particles. I'm just going to shorten the timeline here so we get a little bit quicker feedback. You can see we go to all the different vertices of the target object. So what you can do is actually animate the object, say its shape, or deform it in some way, and you can basically control the particle behavior that way through sort of shape animation or adjusting of the vertices. Line. At this point, the particles will randomly distribute themselves over any edge or iso line or actual curve of the geometry. And for all of these, it's actually a random distribution. So we looked at surface volume. In this case, the particles will go to a random position within the goal object's volume. So you can see we're kind of filling the volume in this case with the particles. And the last one is the center, so the particles will all head towards the center of the object. So let's return back to the point method here. And what we have is we're able to modulate the actual influence of the goal object. So right now the influence is global, so it affects the particles 100% as long as the weighting's set to 1 here. But if we go to local influence, what we can do is create a sphere of influence around the actual goal object. So at this point, the object is too far away to influence the actual particles. As we increase the radius, you'll see we can sort of suck some of the particles over. And we can add a little bit of variability in there to give it kind of random quality to the actual particle motion. And then we've got controls for the weighting here. And this is mainly useful when you have multiple goals and you want the particles, to be influenced by multiple sources. You can animate the weighting to go from one goal to another or modulate the effect to have one have a bit more influence. And that's the way you do it. We can actually offset the goal's position. So basically change the kind of target goal to be in a new area. So we can do that for all the X, Y, Z axes. And if you actually go to the Advanced tab, you have a bit more granularity of control here with the distribution. We can choose between uniform or Gaussian distribution for the radius, as well as the offsetting and the weight. And as well, you have control here for inputting a seed value for those distributions. So that's a quick look at particle goals.